I have a battery problem. So, I have two batteries, one for the big motor, one for the kicker. The big motor battery basically just starts the big motor and does a few little things, but the kicker runs most of the peripheral electronic stuff. My graphs, for example, the live well pump, things like that. And I've been having issues where if I have a brand new battery, things are great for a few months. And then 3, 4, 5 months down the road, I get into a problem where my graphs start to flicker if I fish in a spot for 2, 3 hours at a time. The power steering goes out, stuff like that. I gotta drive my boat around a few miles to use the alternator to recharge things. Now, normally running these kind of electronics is not that big of a problem, but there's something in my setup that throws a big wrench into things that causes me to drain my battery and eventually completely wear it out to the point where it doesn't perform anymore, and I'll get to that later. But to talk about the batteries for a little bit, so I have a lead acid battery that's running this stuff. It's a size 27, it's 12 volt. Now a 12 volt battery, when it's fully charged, will read or test 12.6 volts. If it's fully discharged, it'll test 12 or 10.5. Somewhere in the middle there, about 50% down, is 11.5, 11.6. And at that point is when you start to wind up having long-term damage where you get like excessive sulfation and stuff like that, so I've read, to the point where the battery, even when it's fully charged, it won't last as long as it should last anymore. Now you might be wondering, I have two batteries, like shouldn't I get power from both of the batteries? Well, the way Mercury recommended setting this up is that you put an isolator in there, so your big motor battery does not take a draw from all these other things. They don't want to risk you being out on the water and not being able to turn over your big motor. So what happens is the kicker, when it's running, has an alternator that will charge its battery. The big motor will charge its own battery. But if the big motor charges its battery all the way, then the isolator kicks it over to the kicker battery, so the big motor can charge the kicker battery, which is why I wind up having to drive around the lake to charge things up when I wind up in that situation. So normally these batteries should last for a few years, like 3 to 5 years probably, maybe even longer than that. I'm in a situation where I get 3, 4, maybe 5 months out of the battery, and I keep having to swap it out, and we've tried a bunch of different things, but I think we might have a new plan now to get around this big wrench in the system that's creating all of this damage. So yeah, let's go break that down. And I know you're probably thinking to yourself, am I really gonna take advice about batteries from some guy that's running around in sweatpants? Well, I don't know, that's your problem to figure out. But I am wearing a smart wool jacket, so that should cancel it out, right? Kind of like staying at a Holiday Inn Express or something, I don't know. So as I said, my kicker battery is a size 27. It's got 800 cold cranking amps and 1,000 marine cranking amps, which some people don't think means anything and some people do think means something. Nevertheless, cranking batteries are not rated for amp hours necessarily, deep cycle batteries are, but they can do and run some of that electronic stuff, and they do technically have an amp hour capacity. So there's some math that you can do, and if you do the math, it basically comes out to like 100 to 105 to 108 amp hours, something like that. But they're not necessarily designed for those slow draws over time. They're designed for a lot of power to crank and start your motor and then recharge, and that's it. So if you're running just a few things like the graphs and stuff that I have, not a big deal, but if you got big, consistent draws over time, that can be a problem. So the power draws on my boat, like I said, the graphs aren't a whole lot. I got a Helix 7, which draws like 0.8 amps per hour. I got a Helix 9, which draws like 2.4 amps per hour. I got a live well pump, which draws about 3 amps per hour when it's running. I usually run it on automatic, so it kicks in every once in a while, so it's not constantly running. If you did have something like a live scope, active target, that sort of thing, mega live, those things do take like 4 to 5 amps per hour. So if you have that rigged up on your boat battery and not its own separate battery, that can be a fairly big draw, but I don't have any of that. What I do have though is an electric power steering pump. Most of the Mercury motors these days have those, and they are massive draws. If you're just running the power steering pump as is, it draws about 23 amps per hour. And if you're making a really hard turn and you're really cranking the thing and it's really working, it can drop to 70 amps per hour. Now the idea is that your alternator on your motors can help charge all of this stuff. Well, the big motor does charge about 20 amps when it's at idle speed. And if you're full throttle wide open, it goes all the way up to 85, which is a pretty high powered alternator. The kicker, however, even though it's been improved over time, still only charges about 6 amps when it's at idle speeds, 12 amps when it's wide open, which are almost never running a kicker wide open. So it's about 9 when you're trolling, something like that. So there's a pretty big gap between 9 and the 23, like a 14 amp gap when I'm running my kicker motor. Now, usually when I run my kicker is if I'm trolling crankbaits or if I'm trying to assist in the wind, maybe even if I'm spot locked, something like that, and I just use it for some extra thrust to assist with that. Well, as long as that thing's running, the power steering's running too, and I'm getting a big gap in my amp draw, that's really draining down that battery. Even when I'm just graphing with the big motor, 20 versus 23, there's a little bit of a gap there, and if I'm turning the wheel a lot, it gets bigger the more that I turn the wheel, the more that I work that power steering unit. So now you can see what the problem is. The question is, what do you do to fix that? Well, theoretically, you can use a deep cycle battery for your starting battery. Especially for a kicker, it doesn't take quite as much as the big motor does to turn it over, and it can recover that fairly quickly, and deep cycle batteries are designed for slow draws over time. The problem with that in my case is, since that big motor can charge the kicker motor once its own battery is full, it throws 85 amps of charge wide open. While most deep cycle batteries are not designed to take 85 amps of charge, it'll destroy that battery in short order. That was actually one thing that we tried not knowing that a while back, and that battery lasted like a month, maybe a month and a half, 6 weeks, something like that, and it was shut. But they do have things now called a dual purpose battery, which is supposed to have some of the characteristics of a deep cycle so that it can handle some of these slower draws better and doesn't deplete quite as quickly, but it also has the power to turn over the engine and should be able to accept that 85 amp charge from the alternator. Now you have to check the specs of every single battery to make sure that's the case, but that's the way they're designed, so it should be able to do that if you get the right battery in place. I also, after back and forth and a lot of discussions with a lot of people, learned that you can decouple the kicker from the power steering. So really, I don't need power steering with the kicker. I usually set the kicker on for extra thrust, steer with my bow mount trolling motor, and I don't need to turn the wheel on. If I did, I could still make micro adjustments turning the wheel without power steering. It's not a big deal. That reduces a big part of that gap. Now I still have some of that gap when I'm graphing for fish with my big motor, especially if I'm turning a lot. Doesn't solve that problem, but hopefully between the dual purpose battery and decoupling the power steering from the kicker, that's a big step forward at least in getting to the right place. And also with the dual purpose, I plan on upgrading to a size 31 instead of a size 27. A little bigger battery, a little more capacity in theory. So we'll see what that does. Now, if for some reason these procedures still don't work and I still wind up with this problem, the next step I could do is go to an AGM battery. AGM batteries are a lot more expensive, first of all, but there seems to be some disagreement between some people in this area, but from what I've read, they seem to have a better capacity to handle these slower draws over time, more of a deep cycle characteristic, if you will, more of like a dual purpose battery. So I don't know whether or not an AGM battery would be better than a lead acid dual purpose or not. I haven't used or read too much into the dual purpose batteries yet, but in theory, AGM batteries could stand up to that better over time and not be reduced so far. On the flip side of that, if you do reduce an AGM battery below that, say 50% threshold, whatever that number is, a standard onboard charger can't recharge it anymore. You need a special charger just to get it charged the first time before you can even put it back into use. So there's some pros and cons to that. The other thing I could do is I could remove the isolator. I could link both the batteries together so that everything draws from both batteries. Now that would give me double the capacity, but since I don't know exactly how big of a problem I'm having and how much discharge is occurring with that power steering, I'm then at a risk of ruining both batteries. And if both batteries go dead while I'm on the water, then I can't turn over the big motor and I can't get back. So if I'm 20 miles from the ramp, I don't have anything but a trolling motor, so that's a problem. So there's a risk there. Potentially you could just upsize both batteries, link them together, and never have a problem. But there is that risk that both of them die. So I'm kind of weighing those options. Of course, you could always split the graphs off into a separate battery. I could link my graphs up to a smaller lithium battery that I could put under the dash or something, get another charger for the lithium battery, or plug it into the wall or whatever it is. But again, my graphs don't draw too terrible much. Like, it could lessen the load a little bit. And if I ever got bigger graphs or an active target or a Mega Live, yeah, that would definitely make a lot of sense. I think a lot of people do that. But I don't think it's going to help me too terrible much. So I'm just kind of keeping that in my back pocket for another option. And then the other thing we threw around was maybe just get a separate battery just for the power steering itself and link that in that, put another isolator in there, and so the big motor can charge the big motor battery, the kicker battery, and the power steering battery. And then it's not doing all these other things, it's just the power steering. I don't know, it seems like a lot to have a third big battery in the back, but maybe that's an option down the road too. So I'm gonna see where this goes with the plan we have for now. I don't claim to be an expert in this. I've done a lot of reading and a lot of talking to people that try to figure out this problem. But if I imagine other people having this issue, if you've had an issue like this and you have good solutions or not so good solutions or thoughts or ideas, I'd love it if you leave a comment below and say so. If somebody else has a better solution to this problem, I am all for it. I am all ears. And if not, you know, if you're experiencing the same thing, hopefully maybe this was helpful for you. Maybe you learned something out of this to help your own situation. And if that's the case, I'd appreciate it if you did hit the like button. I'd appreciate it if you consider subscribing to the channel. Maybe consider supporting on Patreon. And we'll see you in the next video. Later, Fisher people.